Well, I guess we can get started. Good morning, or good afternoon, or good evening, depending on where you're joining from, or if you're catching the replay. And welcome to our ZTNA Table Talk series. I'm Mixa Gerard, and I'm happy to have you with us for this ongoing conversation around Zero Trust Network Access. Each month, we dive into key challenges, emerging trends, and best practices for securing modern enterprises. Before we dive in, just a few quick housekeeping items. This session is being recorded and you'll receive the replay within 24 hours. Feel free to drop your questions in the Q&A panel. If we don't get to them during the live discussion, we'll follow up afterward. You can also request translated captions from the menu panel. If you'd like to use that feature, just let us know so we can enable it for you. Now let's get into today's topic, how to build a cafe-style network, VPN-free access that attackers can't even see. I'm thrilled to be joined by two fantastic speakers today. BJ Gardner, Director of IT Development and Operations at Pennsylvania Lumberman's Mutual Insurance, and Adam Rose, VP of Chief Solutions Architect here at AppGate. And with that, let's get started. Adam, over to you.
Thanks. Hey, nice to meet everybody. Today we're going to be looking at how network security is evolving from static perimeter-based models built for the past to adaptive identity-driven architectures built for the way we work now. We'll explore cafe-style networking and universal ZTNA and how it's not just a technology shift, it's more of an operational and business transformation. I'll start with a brief introduction to the concept of universal ZTNA as we here at AppGate see it. And we see it as really broken down into two major concepts. One is the primary topic of today, which is cafe style networking, which is really the concept of treating all your users as if they're remote and on untrusted segments of the network all the time, even when they're in the office. And the second piece of universal ZTNA is around a concept called the principle of least privilege. This concept is for giving users network layer access to only the things they need to do their job and nothing more, taking into consideration their identity, the risk their device represents to the network, and a lot of other items. And so for today's agenda, we're going to be looking at, defining cafe style networking, the hidden cost and security blind spots that traditional VPN solutions put in place, how AppGate Zero Trust Network Access cloaks infrastructure. We'll look at some examples of real-world implementations of cafe-style networking, and then finally the shift from network access to application access, which is really around that principle of least privilege that I talked about earlier. And finally, my friend BJ here will be presenting in the voice of the customer how Pennsylvania Lumberman's Mutual Insurance was able to go from traditional VPN to zero trust network access and finally evolved to universal ZTNA using cafe style networking. So to start with, I'll just give a little background here and talk about how security has changed for the enterprise. As we all know, that enterprises used to be have perimeters wrapped around them, and the users used to be able to be located in a specific area so that you knew where their traffic was coming from. And in the modern world, IT complexity impedes the business growth as things move around. Users are all over the place. They're at cafes, in Starbucks, on the road, on the internet, in offices and branch offices. And the resources they're accessing are also very spread around from multiple cloud environments, different data centers, server closets and branches, and so on. And VPN and perimeter-based solutions are no longer good enough. They result in hairpinning traffic so that users end up having more latency, and they end up giving more intrinsic trust to broad access to network segments. Other vendors are looking at implementing zero trust network access to help solve some of these problems. And they're using cloud routed models where traffic from users are routed through the vendor's cloud. It's decrypted, inspected, and this adds inefficiencies to the user traffic path, resulting in higher latency and lower performance. And at the same time, also requires that you put implicit trust in your vendor since they're going to be seeing all your traffic. So we can look at, the traditional model, which either isolates a user into a VLAN on a network and then provides an ACL that all users in that VLAN go through to get really a broad access and visibility into the network. It relies on the fact that you have trusted inside users that you can trust. And even when these users are remote and connecting via VPN, their tunnel will terminate to a VPN concentrator, and the VPN concentrator will have a very broad set of rules governing what users can do, and again, providing implicit trust and too much access. And we can compare this to technologies like AppGate, which are giving you a zero trust network access model, which only gives the users visibility and access to the things they need at the time they need them. So you're reducing complexity, you're centralizing rules, and there's a lot of business and security benefits to this model that we're going to see as we progress. Zero trust is really driven around identity-based access. So we want a full picture of the user, their identity, how they're behaving, and their device. What is running on it? What risk does it represent to the system? And all these factors combined will be taken into consideration and fed through a rules engine, which will determine what each individual user will be able to get access to at any given time. The concept of zero trust means isolating each user into a segment of one, which basically means there's a micro firewall between that user and the environments that they want access to. And that micro firewall is dynamically changing based on the behavior of the user, their identity, and the posture and context of their device. Traditional VPNs and VLANs, where users are on net, are used to segment users away from the network, and they're designed for a world where users are inside the perimeter and trusted. The VPN will attach remotely the user to the perimeter and virtually bring them inside of it. And when a user comes into the office, they'll be put into a VLAN or a segment on the network where they're given access based on where they're sitting in the network. The world where you can trust your users no longer exists. Cafe-style networking embraces the reality that users, devices, and workloads are everywhere, and the threat from the trusted insider exists. And security access has to follow your users seamlessly wherever they are. So when we look at cafe-style networking with Universal ZTNA replaces location-based trust with adaptive, identity-driven access that's consistent anywhere the users are. It strengthens security by cloaking the infrastructure, making it invisible and undiscoverable, and enforces least privilege access, ensuring that each user only gets access to what they need. While at the same time, it simplifies operations and accelerates business agility, delivering stronger protection, lower costs, and a frictionless user experience. The concept of ZTNA and cafe-style networking is, like I said before, treating the users that are in the office as if they were remote. Yes, they're on a high-speed, low latent connection, and they want to feel like they're in the office, but at the same time, you want to only give them access to the things they need and when they need them, and treat them the same as if they were remote. There are hidden costs to traditional VPN solutions. Traditional VPNs and VLAN-based security where users are in the office create excessive trust. There's high operational overhead and dangerous visibility gaps. Universal ZTNA replaces static network-centric controls with adaptive identity-driven access. It reduces risks, eliminates complexity, and delivers a measurable ROI through stronger security and simpler operations. We do this through several concepts, which we're going to review on a high level today. And I also wanted to say that anytime, if you guys want a deeper dive into your individual use case or requirements, we can do one-on-one meetings with you moving forward. But once we break dependency on the network or location of the user, the next question is visibility, because you can't attack what you can't see. That's where AppGate's single packet authorization completely changes the game. We want to hide the infrastructure so that remote actors can't find it. And if they can't find it, it makes it much more difficult to attack. To do this, AppGate uses a technology called single packet authorization, and we use the word SPA for short. This technology makes infrastructure invisible to unauthorized users on a network layer. It eliminates the external attack surface, stopping reconnaissance before it begins, and it prevents discovery rather than responding to compromise. Organizations can shrink operational burdens, and strengthen security while improving their ROI. The way we do this is we use SPA to cloak the listening port that is used for user connections to gateways where their traffic flows to get access to all the private infrastructure that you're protecting. SPA cloaks the three-way handshake, and it will only respond on a network layer to users who have already been successfully authenticated and whose posture, context, and identity merits access to the environment that they're trying to get access to. So cloaking the infrastructure makes it impossible for people to discover it, and that makes it very difficult to attack, eliminating zero-day and denial of service attacks. So now we can look at a real-world implementation of what cafe-style networking might look like. We can look here and we can see that you have a traditional user who's on the internet that remotely accesses a server segment inside of a branch or a headquarters office, or this could be a data center or other areas. If this user were wanting access both to this branch and to the data center over here, they could also make a connection from themselves to the branch as well as the data center directly using a direct routed model with AppGate ZTNA. So the remote user cannot see anything when they scan IP addresses and look for the network edge. They won't see the AppGate infrastructure at all because of SPA, making these segments invisible and protecting them from those remote users on the internet. When a user comes into the office, traditionally they'd be put into a VLAN that is co-resident on the same network as the server segments and as the WAN connection to the data center, allowing them to see a lot of open ports to things they may or may not need access to. Instead, we want to move users into cafe-style networks, very similar to the way that companies do for guests or contractors today, where you come in and you end up on the guest Wi-Fi, and the only thing you have access to is the internet and nothing else. The same will be true of your employee users. You can locate them in your existing guest Wi-Fi segments, or you can create employee-only internet-facing Wi-Fi segments, where when the user actually attaches their device, all they have access to is the internet, and the AppGate gateways separating them, just like the remote users from your important infrastructure, are invisible. So if some malicious user were to come and get on the guest segment, there'd be no open listening ports and nothing they could find. By placing these users in this cafe segment, you're giving them the same access to the high-speed, low-latency network that you guys have created for server access, yet you're hiding all the critical infrastructure from them and only providing access to each user as they need access to what they need, isolating each user into their own segment, just like you are your remote users. By treating your on-net users the same as you treat your remote users as untrusted, you increase your security posture greatly. So now that we've looked at sort of how cafe-style networking looks, we're going to take the biggest leap forward and we're going to shift from network access to application access. Instead of connecting users to entire segments of networks, we're going to put controls on them that give them access to only the applications they're authorized to use at the time they're authorized to use them. And that comes in the form of, the industry calls this the principle of least privilege, but it comes in the form of, dynamic entitlements and segment of one, like we talked about earlier for users with AppGate. The shift from network access to application access, the move from network-centric to application-centric access transforms security by improving the principle, by enforcing the principle of least privilege at scale. AppGate ZTNA dynamically grants users access to only specific applications they need and nothing more. This eliminates lateral movement, reduces complexity, and aligns security with business agility. If you think about traditional solutions where you're putting a set of ACL or access control list rules between the users and the rest of the network, every packet that the user sends traverses the ACL until it finds a rule that defines whether that packet should be allowed, dropped, or maybe alerted on. So you have these enforcement points all over the place that are independently managed and have to be configured separately. This adds complexity. With AppGate ZTNA, all of your entitlements are central. When users authenticate, they're connected to gateways directly from their device, resulting in the shortest path possible between the user and the resources. And then between the user and the resources in the gateway, dynamically is configured an ACL just for that user, resulting in a segment of one for the user. And that ACL, the access control list that the user's traffic is going through, is for that user only and only contains the rules that are relevant to the user's needs at the time when they're accessing them. We use a concept called dynamic entitlements to provide this, so that when users authenticate based on their role, the posture and context of their device, their location, the time of day, or other criteria you might want to scan, the user is granted a list of dynamic entitlements. Those entitlements adapt themselves to the user's current posture and context and result in a firewall between the user and every segment they're connected to that's just for them and only contains the rules allowing them to see and connect to what they need at the time. When you combine the architectural shifts of context-driven access, invisible infrastructure, granular control, and granular entitlement access, you get stronger security, simpler operations, and a measurable ROI. This is what makes Universal ZTNA not just a security tool, but a business enabler. So I've given you a brief introduction and a high-level overview of cafe-style networking, Universal ZTNA, and the principle of least privilege, along with SPA to cloak infrastructure. And now I'd like to turn over the presentation to BJ Gardner from PLMI so he can describe the journey that Pennsylvania Lumbermans took to transition from VPN to ZTNA for remote access, and finally added on cafe-style networking and full universal ZTNA. So BJ, if you want to introduce yourself real quick, and I'll turn the floor over to you. One of the questions I had for you to begin with was, why did you choose AppGate? What made you decide to go from traditional VPN to ZTNA for remote access?
Adam, thanks for having me on the webinar today. Appreciate it. Hello, everyone. As stated in the beginning, my name is BJ Gardner. I'm from Pennsylvania Lumberman's Mutual Insurance Company. So we're a commercial insurance company that had the same challenges as every other industry out there when we sent everyone home around the COVID time. So we were traditional. We were in the Philadelphia-based headquarters with a full physical on-prem network. And when the entire company was sent home for COVID, it presented a challenge because all the users, although they had VPN and they were coming in, over the network, it presented a challenge since users were all over the country at that point, and they were coming in through the single data center in Philadelphia to get to all their apps, spread over a few data centers around the country. So presented a challenge to us. So we initially did look for a VPN replacement solution. We wanted a cloud solution that could offer more efficient routing for VPN capabilities. But we were also running a kind of a security project to look at the zero trust landscape. So we wanted it to scale for zero trust initiative, but also be a VPN replacement for us at the same time. So we did review a bunch of vendors. We had a whole vendor review process. And like I said, we wanted a solution that could scale a universal ZTNA and be a VPN replacement for us. So that's
So it sounds
kind
like
of
you
the
were
background.
struggling with,
Yeah,
sorry, BJ. Yeah, it sounds like you were struggling with user performance issues due to having
we
to
were.
send all the user traffic through a central data center before sending it out.
That is
And
correct.
there was also some zero trust concerns. Maybe your attack surface was visible on the net, and that was sort of the driver to get you to consider moving away from VPN, is what it sounds like.
It was, and I can tell you that I know in the presentation we talked a lot about the physical infrastructure at a data center or an office, but we have a lot of cloud apps as well and third-party vendor apps, and without the VPN, you could simply disconnect from the VPN and you could get to all those cloud apps still. You're not in the office, so you don't have the protections of the security tools that are running from inside the office. So that presented another kind of risk to the company as well.
And then this was during COVID, so all your employees, I guess, were forced to work at home. How are you aligning your users with the entitlements or the privileges they needed to access using AppGate? What tools did you guys use to help enforce that alignment of users with just what they needed to access?
Yeah, so just real quick, I'll just step back and just talk about the decision-making process. So one of the biggest advantages that we saw when we were choosing a vendor in this space was the direct routing capabilities versus just cloud routing from some of the other vendors. The ease of deployment of AppGate, no bottlenecks or risk with traffic moving through vendor data centers. This was direct routing, so we didn't have to worry about a cloud data center where all of our traffic was going through. The disaster recovery on AppGate was seamless as long as you have connectivity. And your gateways are up, you have connections to all of your apps. Even if the backend controllers are down, say from the AppGate cloud perspective, all of your clients function on whatever the latest policy is that was enforced. So the disaster recovery was much more seamless with AppGate. There's gateways running at each of the data centers, even the big cloud. We have gateways running at our big cloud data centers as well. And there was cloud app integration through AppGate. So when you have your on-prem data center, you're worrying about the apps and the the network access you have in-house there. You may have some rules going outbound to your cloud providers, but you can bring all those cloud apps through AppGate, so you can lock down access to those cloud apps and third-party vendor apps to only AppGate routes. So it
That's
provides
great.
another layer of security on top of just entitlement based.
So that's
So
how
it's a
you're
kind of a
securing access to SaaS apps, it sounds like.
correct. Yeah, you can lock down the SaaS apps to AppGate traffic only. Therefore, a threat actor trying to get to your tenant, again, we're not hosting it. So a SaaS app, we're not hosting. A third party trying to get to our tenant in that SaaS app, it only has routes for AppGate. So it locks down even the routing. So if you have a device with AppGate on it with the right entitlement as a user in the network, you can get to that app. So users inside that are PLM users that don't have the entitlement can't even get to that SaaS app.
Yes, I guess that allows you to wrap the posture and context and risk controls and the dynamic access that AppGate provides around accessing SaaS apps as well. And do you run any like infrastructure in the cloud or no?
Yes. Yep.
And
We have
so you could put
third
AppGate
party
gateways
cloud.
in that infrastructure, allowing
Yes,
direct routing, I think is
that is correct.
yeah.
So we do have in our big cloud providers, we do have gateways in those clouds as well.
That's excellent. So you were fully deployed for remote access during COVID. All your users were remote. And then what drove your decision to continue to enforce access using AppGate as users started returning to the office?
Yeah, so we did have an initiative this year, actually, in 2025, to bring staff back to the office. Now, so, over the 6 years or so, people were out of the office. We changed some hiring practices. So we were hiring around the country as well. So the footprint's a little different. We're still all over the country, but we are bringing a Philadelphia-based workforce back to the office. And we did that in September. And so what AppGate, so we didn't want to take people off AppGate just because they were sitting in the office, like kind of like a traditional VPN would have done.
Sure.
So AppGate does allow the flexibility to with what they call a use local feature. So the traffic, so they sit down at their desk. As Adam said earlier in the presentation, they are dropped into a cafe or guest style network when they get here, when they plug in. And AppGate is still doing the routing through the gateways the same way it would if they were sitting at their house. But the use local feature allows the networking to go directly from the client, and AppGate knows that it's local and can go directly to the gateway instead of going out to the internet and back in. So it's a much more efficient and seamless process. We don't have to take people off of AppGate when they sit in the office, which is the intent of what the café-style network is.
Yeah, I know you mentioned the use local feature. That's one of the features that AppGate has in its playbook. It's designed really to be not just remote access, but universal ZTNA. So wherever the users are, whether they're on net, off net. And so we have a lot of features that are designed to help customers get to that on net universal ZTNA implementation as quickly as possible. And the use local feature is a great one. It sounds like you're getting use out of that. Like you said, we're able to detect.
Yep.
You're able to detect when the user is actually in an office, which office they're in, and then we're able to route the traffic from that user to the AppGate gateways in that office using the high performance, low latency LAN that's in place, so the users feel like they're in an office, but you're still able to have the security controls as if they were remote. So
That's correct.
That's great. That's just one of those. There's a lot of features built in AppGate to make the transition easy. What was your experience configuring? Like you had all your users remote, they started coming back in the office. I know that's a different connection paradigm. So how difficult was it to actually transition AppGate from just remote access to actually putting on-net users through it as well? Did you have a lot of difficulty? Were there a lot of changes you had to make?
There was not. I mean, from the Wi-Fi perspective, like you said, we had the guest VLAN and we dropped all of the Wi-Fi on the guest VLAN, and then used AppGate to do all of our routing and access control. And then on the Ethernet side, so yeah, we have a physical network in here too. We have Ethernet going back to the switches. We just took the user VLAN that was at everyone's desk and we moved that to point directly, out to the internet like a guest network would do. With again, AppGate using the use local feature, they're able to route through the gateway seamless without having to go out to the internet and come back. So whether you're on Ethernet or wireless, you use the guest cafe-style network, and AppGate's doing all of the access control and and routing. So
yeah, we find a lot of our customers actually do that. They'll mix users into their guest network because it's already there, and it makes things
already
really.
there. I mean, you have a guest VLAN on the switch that's already there for the wireless. So there was really little to no configuration or changes needed. Just one quick VLAN change on where the traffic's going to go from the Ethernet VLAN, and that was really it. We took away the user network from the Wi-Fi and So you're left with one Wi-Fi. It actually makes your maintenance on everything kind of goes down too. So it's kind of a win-win.
And AppGate's got functionality
Yeah,
built in so that even though you're mixing users and guests on the same segment, we can protect those users and their devices and their traffic from those
correct.
guests. So we were really designed for that. And that came out of, like, imagine a user's at Starbucks, right? You don't want other people at Starbucks to see what the user is doing or be able to
No.
see the user's device on the network. So we have a lot of functionality built in, and that's really what AppGate's all about. Is there anything else that you wanted to talk about for your transition, while we have you here on this webinar? Thank you for joining us today, BJ.
Yeah, absolutely. Again, I appreciate you inviting me. So I do have one other topic that I like to go over because again, AppGate, it as you can see, it does a lot and it brings a modernized approach to VPN lists and zero trust and networking. But it does do integrations, and you do have the choice of identity providers, obviously.
Mm-hmm.
We are using Entra ID through Azure, just so the audience knows. And Entra, it does work in tandem. So our Entra groups, our security groups are hooked up to the entitlement. So we are doing all of the access control right from Entra for the most part because it's tied to our security group. So I just want to make, in
Oh,
case
that's
there was
great. Yeah, so it
questions
sounds
that
like the
came up.
security groups and
Yeah,
Entra define what access the users
correct.
are getting, which is
Yeah,
great. And that's one example of an integration. You can integrate
yep.
AppGate for just-in-time access for, with
Mhm.
ticketing systems and such, but aligning users with the access they need based on the groups they belong to or security groups they belong to and the identity provider. That's a
Yes.
very
So
common thing. Yeah.
it is, and they're all dynamic groups. So based on their onboarding, it's all automated from the time HR puts in the role into the ticketing request for the onboarding. So depending on their department and their title, it even goes by their title. They'll
Mhm.
be assigned the enter groups that then are already set up in AppGate, so it's completely seamless, hands-off access to their applications.
That's awesome. Well, I know that we have some links that Ixta is going to share in the chat window. I just wanted to thank everybody for coming and being here with BJ and I today to be part of this short table talk. I know we'll be doing another one soon, so thank you all. I know that Ixta is going to share. We have like a 5-step guide of how to get from VPN to ZTNA. And I wanted to open the floor in case anybody who was on the webinar that's attending had any questions for us.
There was one in the chat already. If I don't know if you wanted to answer that, Adam.
Oh, I can't see the chat.
Yeah, I have it here for you, Adam. It came in earlier at the beginning of the presentation. It's from Michael.
Okay.
How is this any different from a traditional VPN setup with user ID or security group based security policies, device posture checking, and properly crafted security rules?
Really great question, and I appreciate that, Michael. So the difference is AppGate and Universal ZTNA in general operates on a non-trust continuous validation model. So like a traditional VPN will take the user's posture and context of their device, and will take their identity and potentially align them based on groups in their identity provider. And usually a VPN, what it will do once it aligns the user with groups, it'll give the user an IP from a tunnel pool that pre-aligns with ACLs that are pre-built in the static rule set of the VPN. And so remember, we're controlling access based on your source. And in this case, the VPN has to give the user a specific source IP so it aligns with the correct rules in the VPN. Once the user's posture and context has been taken into consideration, their authentication has been validated, they're attached to the VPN, and those items are never remeasured again throughout their session. So one important thing that you want with zero trust network access is you want to continuously revalidate. Just because a user's firewall was running or their AV was running and there was no viruses detected on their system at login doesn't mean that at some point throughout the day that might change. So continuously revalidating that posture and context throughout the user session and adjusting their access dynamically by adjusting the ACLs as their posture and context changes is one major differentiator between a traditional VPN and AppGate. The other one is what we talked about earlier with the cloaked infrastructure or SPA. All VPNs operate by having an open listening port on the internet because your users could be anywhere in the world. If I send a SYN or a three-way handshake request to that open listening port, it's going to respond and it's going to give me details about the type of VPN it is, what vendor made it, and all these details can be used to construct zero-day attacks or to discover where the VPN concentrators are and denial of service attack them. So adding SPA on adds an additional layer of protection to ensure those things don't happen. I hope that answered your question fully, and if not, please feel free to elaborate.
Thank you.
Michael did have a follow-up actually.
Yeah, he did. He did. Most NGFWs allow you to craft security rules around the user ID or security group,
Mm-hmm.
and many VPNs allow constant posture checking. I'm not sure that's a question.
Question, more of a statement. Yeah, I mean, consistently continuing. Yeah, so next gen firewalls with next gen VPNs may have some of this functionality. Again, we have dynamic entitlements. So the other piece that we didn't talk about is how the rules are derived. Most next gen firewalls allow you, like you said, to specify that Adam can access certain maybe applications with specific application IDs. So there is some metadata in there that you can use to resolve the fact that even if Adam moves or changes, it's still Adam, and the destinations are still identified by, like you said before, maybe the application IDs. So as applications move or their IPs change, their application ID won't, and that access will stay the same. But if you take that to the nth degree, like with AppGate and Universal ZTNA, we have this concept of what we call dynamic entitlements. And what that means is that the target field, which usually represents the names of the servers, like the host names, or lists of IPs, or lists of application IDs in the case of next gen firewalls that define the targets. The target field eventually gets resolved down to IP. So for example, in a next gen firewall, if you specify an application ID as the target, the next gen firewall will go out and try to figure out what the IP of that current application ID is right now. It'll derive that and add that dynamically into the user's session. AppGate does similar for target information, but beyond just application ID, AppGate can resolve almost any metadata in any environment. So for example, if you have an inventory database somewhere, or if you have tags on instances running in cloud infrastructure environments, the target field can derive the actual destinations that need to be accessed through any metadata by accessing databases, tag fields. So for example, in VMware, certain servers may be in a certain type of folder, like finance servers may be in the finance folder. So the target of the entitlement could be things in the finance folder in VMware, or things in the cloud environment tagged QA or prod, any type of metadata. So we take that next gen firewall concept of app ID and we take it to the nth degree by allowing you to resolve any metadata down to target fields. And in addition to just the target, we also allow you to dynamically resolve ports and protocols. And so that allows you to do things like just-in-time access. For example, I could give you access to things you have an open ticket for in an ITSM or things like that. So we take those concepts and we take them to the next level.
Thank you, Adam. We have a few more questions that came in. Someone is asking, I want to ask a tech question. Is it possible to set up portals in HA? I'm not sure about the acronym. If not, why?
So I guess they're referring to the AppGate appliance portal function, which is our SSL web VPN front end that allows users without a client to simply use any browser to attach. And then there's a virtual version of the AppGate client for that user in the portal appliance that proxies their traffic into AppGate protected networks. So if that's the portal you're referring to, the AppGate portals can be used in HA. They can be put behind load balancers or content networks, and traffic can be directed towards different portals based on load or whatever you want. So that is a function that we do support today.
Thank you, Adam. Here's another question. Can access be granted based on country, time of day, and specific IP or geolocation context?
Absolutely. Any metadata that you can query via API RESTfully can be used as part of the access decision making. We have very granular policy elements that operate on Boolean evaluators. So for example, if you're in the right country and it's the right time of day and there's an open ticket on the destination, then that users in group XYZ will get access. So absolutely, the answer is yes.
Actually, yeah, just to follow up there, that was one of the features that we utilized because of a lot of West Coast. We're an East Coast based company. We have West Coast users, so we utilize that geolocation features.
Great. Awesome. Yeah, so you're making use of that. It could be any metadata, honestly, like that you can query via API.
Wonderful. We have another question here. We use RDP for an app access with a secure gateway for remote access. Would this replace that? Would this replace VPN?
This would replace VPN, and it could potentially replace your RDP access. Like if your users are RDPing to their, for example, maybe they VPN in an RDP to their workstation, we could give them more direct access. We also have customers that have VDI or clusters of servers that are designed to allow users to remotely access and into the network, and the AppGate client can actually be run on the RDP servers. And the AppGate client has modes that it can run, and one of those modes is the multi-user OS mode. So if there's an RDP server with a single OS that multiple users share, maybe there's 4 or 5 or 6 users logged into it at any given time, each with different access needs, the AppGate multi-user mode for the client can differentiate each user and what they need to access on the network and give them each their own individualized access. So there are cases where we replace jump host type solutions where users are RDPing into a server and then using that as their access into the network. We can replace that sometimes, but there are some circumstances where the two can work together, and it depends on your requirements. If you're needing, for example, to stop users from downloading things from the network, and you want to sandbox or isolate all the things that they're interacting with into an environment that you control, then putting some kind of solution that allows RDPing in, like a VDI or Citrix on the head end, and then adding AppGate on top of that, that's a really good option. But if your concern is more just controlling users and what they can do based on their identity, then just allowing direct access and replacing that completely is also an option.
Thanks, Adam. One other question came in from someone else. Can we set up RDP access with agentless portal?
That is a feature that we have on our roadmap. So today, the agentless portal only supports web-enabled apps. So the way you would do that today is the user would use their browser to connect to the agentless portal. The agentless portal would instantiate a version of the AppGate client for that user and connect them to gateways, and their traffic would flow from their browser as web traffic into the portal, through the tunnel, and out the gateway. So it would only be web apps that they're able to access in that model. However, if behind the gateway you were to put something that could translate web traffic into RDP traffic, like Guacamole or something like that, you can do that today. However, we do have features on our roadmap to add that functionality directly into the portal. So that is something that's coming for RDP and SSH type access.
Thank you, Adam. It looks like those are all the questions that we have for today.
Well, awesome. Well, those are really great questions. I really appreciate the participation, and I'd really love to dive deeper. And any of you guys who asked questions that really didn't get as deep of an answer as you wanted, I'd be glad to meet with you guys one-on-one and dive deeper. And appreciate everybody taking the time, and I appreciate you, BJ, for joining us today and telling us your story and how Pennsylvania Lumberman's got to Universal ZTNA.
Yeah, thank you.
Thank you to our speakers today, BJ Gardner and Adam Rose. Thanks for your time and for sharing your insights. And to our audience, thank you for being part of today's ZTNA Table Talks. As a friendly reminder, the recording of today's session will be shared with you tomorrow. We highly value your feedback, so please take a moment to complete the short survey at the end of this webinar. Your feedback is instrumental in shaping the future of our future ZTNA Table Talks. Thank you once again for joining us, and have a wonderful day.
Thanks, everybody.
BJ, thank you, Adam.